Hello students, welcome you all in the lecture series of numerical interpolation. We have seen the basic concepts related to this numerical interpolation for applying the Newton's forward interpolation formula. Basically, we have to study in this interpolation the operators, forward difference operator, then backward difference operator, shift operator, then average operators. There are many more operators. But here we will see restrict our talk to forward difference operator and shift operator only. So we already seen about the forward difference operator. Also we have solved examples on Newton's interpolation formula using this forward difference operator by constructing the forward difference table. In the previous lecture we have introduced what is shift operator and its relation between forward difference operator and shift operator. In this lecture, we will solve some examples based on this relation as well as separately on the shift operator. Let us see the examples. Now you can see this example in which we have to find the missing term. Generally, this relation is used to find value of function at any given value of x as well as to find the missing term. So generally we have examples of this type in which we have to find the missing term in the table. So here if you observe this table, values of x and some values of y are given to you. Before we use this formula, first we have to check whether this x is equally distant points or not. That is, increment must be same. So here if you observe x equal to 0, x equal to 0, then x equal to 1, x equal to 2, x equal to 3, x equal to 4. It means that h equals to 1 here. That is, it is fixed. So these values of x are equally spaced. Now we can use the relation here and we can find the missing term in this. So if you check values of y, you have given values of y0, y1, y2, y3 is not given, which we want to find, and y4. Initially when you have this table, you give the name to the values as x0, x1, x2, x3, x4. Rather we want only the value only for y's. So basically you give values for y as y0, y1, y2, y3, y4. Okay, now here like the forward difference table, we don't want to construct here the forward difference table. Directly from this table we will solve these examples. Now here first you have to check how many actual values of y are given to you. So here accept the value which we want to find. So here if you observe, we have given y0, y1, y2 and y4. So total how many values you have given? 1, 2, 3, 4. So here you count values only how many values are given. Not from 0, not from starting from 0. You just count how many values are given. So here 4 values are given. So as 4 values are given, if we find the fourth power of this forward difference of this y, then it is equals to 0. As 4 values are given, delta raised to 4 y0 equal to 0. Here y0 is important. If we write here y1, then it will be wrong. Here y0, generally we consider only the forward differences of y0, delta y0, delta square y0, delta cube y0 and so on. So as here you have given 4 values of y's, delta raised to 4 y0 is equal to 0. But we have seen that the relation between the forward difference operator and the shift operator is delta is equivalent to e minus 1. So as we have seen in the lecture 6 that how to find powers of this relation using the binomial expansion. How to write in directly within 1 minute using the binomial coefficients obtained from the Pascal triangle. So we will make use of this. So therefore delta raised to 4 y0 is nothing but substituting value of delta as e minus 1. Here it is e minus 1 raised to 4 y0. Now, as explained in lecture 6, here directly I have written the expansion, that is write powers of e in decreasing order. So here decreasing order we have written. So maximum power of this bracket is 4. So first term of this expansion is e raised to 4. Maximum power is 4. So first expansion is e raised to 4. The next term is e cube decreased by 1. The next term is e square. Then e raised to 1 here, and here actually e raised to 0, but e raised to 0 is 1, so we don't write it. After that we have given according to the step giving alternate positive negative sign. So first term has positive sign, second term has negative sign, then positive sign, then negative sign, and then positive sign. And then as we have seen in this Pascal triangle, that what are the binomial coefficients for n equals to 4? 1, 4, 6, 4, 1. So just pick up them and substitute it here. Look at here. 1, which is coefficient of e raised to 4. 4, 6, 4, 1. So within 1 minute you can write down expansion of this bracket. But as delta raised to 4 y0 equal to 0, here we will substitute value of delta raised to 4. So delta raised to 4 y0 equal to 0. So substituting value of delta raised to 4 y0 as 0 here. So 0 equal to, now here as we are applying it on the function, we will write here equal to sign. Okay. Then it is equal to, as this expansion, e raised to 4 minus 4e cube plus 6e square minus 4e plus 1. And this whole operator, this is the operator actually which is operated on y0. So now we will split this, open this bracket, and we will consider the separate terms. So what is the first term? E raised to 4. So e raised to 4 applied on y0. So it is e raised to 4 y0. Then minus 4 will be as it is. So minus 4 is as it is. Then now next means e cube. So e cube on y0. So e cube y0. Then plus 6 here and e square y0. We are not multiplying it. Again, you remember this thing. We are not multiplying. We are operating this operator on y0. So do not take it in that way. We are operating it. So minus 4e on y0 and 1 y0 means this is here identity operator actually which is operated on y0. So here the term is y0 itself. Now we have seen the formula for e raised to n. So again I can show you that formula here. General formula which we have written for this. Let me be here. So here what is this formula? E raised to n yk equal to yk plus n. So k is what? Suffix of y. N is what? Of order of the operator. So now let us go to this example. So here we have to obtain, see this example. Okay. So now here we want to obtain e raised to 4. So n equals to 4 here, right? So here n equals to 4. And what is the suffix of y? As 0. So that is k equal to 0. K equal to 0. So what will get? It is 0 plus 4. So that is y4. Then here 4 is as it is, minus 4 is as it is, and e cube y is y3. Then plus 6 is as it is. Then e square y0 is y2. Then minus 4 is as it is, and e on y0 is y1, and this y0 itself. Now you have to pick up values from the table. So substitute the values of y0, y1, y2 and y4 in the formula. Here the missing term is y0. So let that y3 will be as it is. Okay. So automatically we will get value of this y3. So y4 is 51. You can check it here. I will just show. So y4. Here the value is y4. y4 is what? This 51. Okay. So here I have kept it 51. Then y3. Here which we want to find. So y3 is as it is. Okay. Then y2 is 6. Here it is 6. So substituted in the brackets 6. Then minus 4 y1. So y1 is 2 here. Substituted here 4 into 2 and plus y0. The y0 is 1 here. Y0 is 1. So we will substitute value of y0 as 1 here. This one. Yes. So here we will substitute it. And now what we have to do? Only the calculation. It's very now obvious. So 51 minus 4y3. Now 6 into 6 is 36 here. 4 into 2 is 8 and 1 as it is. So if you do calculation of this 51 plus 36 minus 8 plus 1, then it is 80, and this minus 4y3 is as it is. So therefore what is the equation? 0 equal to 80 minus 4y3. So therefore solving this equation, 4y3 equal to 80 here, taking to this side 4y3 taking to LHS, what will get? 4y3 equal to 80 means y3 equal to 20. So it is very easy to obtain value of missing term using the relation between forward difference operator and shift operator. Even if we want to find, suppose here if you have given all the values and the question is that find value of y5, then also that we can find using value of this delta. So for this, now here you have to consider 1, 2, 3, 4, 5. Means here obviously all the values are given. Then here you consider delta raised to 5 equals to 0. So automatically you will get value of y5 here. Let us go to the next example. Same example. So these are the examples from the question bank which I have already put on the group here. So this is example number 43. This was example number 36. And only here, this is only the format of the example. Only the figures will change. Otherwise, the method is same. And I have explained to you how to find powers of this bracket. So it is very easy to solve this type of question if you know the binomial coefficient, the Pascal triangle properly. Then next example, let us go to the next example. So here we want to find the missing term for y1 here. Means here y1 is missing. You can see this example here. Y1 we want to find. Again here if you check values of x, then what are values of x? 1, 2, 3, 4, 5. So here h equals to what? 1. Actually in this example we don't need h directly. Also we don't need values of x. Nowhere we are using values of x and h, but here it is very essential that the values of x must be equally spaced to apply the shift operator formula or forward difference operator formula or relation between them. So here same. So here again how many values are given? Actual values are given except the missing value. So how many values? 1, 2, 3, 4. So that's why 4 values are given. So delta raised to 4 y0. So here I have given proper expansion of this e minus 1 raised to 4 using binomial expansion here. So as I have told you the direct way, then this is the expansion equal to 0. So same I explained in the previous example. Doing the same way, e raised to 4 y0 minus 4 e cube y0 plus 6 e square y0 minus 4 e y0 plus y0 equal to. So that is y4 minus 4 y3 plus 6 y2 minus 4 y1 plus y0 equals to 0. Substituting the values here. What is y4? I'll show you. Y4. So y4 is 37. Look at here. So substituted here 37. Yes. Then y3 is 21. So y3 is 21. So substituted here y3. Here it is 21. Okay. Then y2 equal to 13. Here the value is 13. So here plus 6 into 13 here. So 13 here. Okay. Then y1 is missing. So y1 term is as it is. That is minus 4 y1. And what is y0? Y0 is 7. And now simply you have to add these values and solve the equation. So the values are 38 equal to 4 y1 equal to, here it gives me value of y1 is 9.5. Now how to check our values whether it is correct or not? So what value we are getting? 9.5. So just check value of y0 and y2. value of y1 must lie between y0 and y2. So what is y0? 7 and y2 is 13, and what is y1 which we are getting is 9.5. So our answer is correct. In the previous example also you can check here we are getting y3 equal to 20 and here y2 equal to 6 and y4 equal to 51. So it lies between 6 and 51. So our answer is correct. Okay. So in this way you can solve any example based on this relation between forward difference operator and shift operator using this formula, and even you know how to find powers of delta as well as this bracket, how to expand this e minus 1. So here just I want to show you the general binomial expansion of this, how we can write it. So n equal to, so for n equal to 8 I am giving, so you can use it for any bracket. So here for particular cases in the previous lecture we have taken a particular case which we require here for e minus 1. So that we have done as an practically how to do it, but generally wherever you want to expand the bracket you can use this formula. So here I have taken one example as n equals to 8. So according to this Pascal triangle, the binomial coefficients are, here I'll show you the binomial coefficients which we have obtained here. Yes, n equals to 8. So it is 1, 8, 28, 56, 70. So you have to only remember this, because if you observe then these values repeats. So here 70 is the middle point, because n equals to 8, how many values will exist? 9 values will exist. So it has a middle point which is 70. And if you observe this first half, this is 1, 8, 28, 56. So in the reverse order this value are here 56, 28, here 56, 56, then 28. So here is 28, then 8, then here is 8, and last 1, 1. Why this is so? Because we have the formula. Which formula? If you remember, I had given in that lecture that NCR is equals to what? N C N minus R. Okay. So suppose here n equals to 8. So now yes, we are taking the example for n equal to 8. So let me write. So here if I'll calculate value of 8C3. So 8C3 must equal to 8C and 8 minus 3. N minus R here. So it is 8 minus 3. And what is 8 minus 3? Which is 5. So it must be equal to 8C5. Yes. So if you see here in this Pascal triangle, 8C3. Where is our 8C3? Here is 8C3. Yes, just check it. So it must equal to 8C5. So where is my 8C5? This is my 8C5. This is my 8C5. Here I can see. Similarly, 8C2 must equal to 8C6, because 2 equal to R and n equals to 8. So 8 minus 2 is 6. So this is equal to 8, 6. So only just pick up these values and always remember the see the coefficients, that half coefficients are same here. In case of even terms, here if you see even, here n equals to 5. So how many coefficients will exist? 6 coefficients will exist. So 3 are same. So 1, 5, 10, then 10, 5, 1 in the reverse order. So in this way these coefficients are. So while writing, take care of this thing, that whether we are writing them correctly or not, and check it. So okay, so here the coefficients are 1, 8, 28, 56, 70, then 56, 28, 8 and 1. Okay, so let us go in that table. So here we have this coefficient 1, 8, 28, 56, then 70 was the middle, and then 56, 28, 8, 1. So how many terms will be there in the expansion? 9 terms will be there. So let us go to this general expansion I am explaining to you here. So here if I consider a plus b, now everybody know that a plus b bracket square, then it is a square plus 2ab plus b square, then what is a plus b bracket cube, that also we can write. So now using this binomial expansion, now if I want to find the power of this, then here let me write it as an power. Yes. Okay. So now I want to expand this bracket. Okay. So now here the rule is that A is my first term. Here A is first term. A is first term and B is second term. Now you have to pick up it with along with its sign. So if it is minus B, then pick up it as small a, and here it is B. So pick up it with its sign. So here both I have considered as positive, negative also I will tell how to pick up them. Then first thing is that like this, that we have written all this in the decreasing order. And here why only E? Because powers of 1 are 1, and then that's what we have not considered powers of 1. But here as these two are different terms, we will consider powers of A as well as powers of B. So let me write it. So it is first term will be, now maximum value of n is 8. So first term will be A raised to 8. So A raised to 8 I have written, and then here B raised to 0. So always the first term is like this, that highest power will be for the first term and 0, because we will starting it from the power 0 and we will end it to the power highest. It just get reverse, and 0 and 8 in the final table, final term we will get. So here first in the first term we will have A raised to 8, B raised to 0. So I will put it as in powers afterwards. Let me write it first now. Then I will get it as A raised to 7. Now power of A will be decreased by 1. So here 8. So therefore here we will get power as 7. Now power of B will increase by 1. So here I will have A raised to 7 B1. Then in the next term, power of A will be decreased by 1. So A raised to 6 and B raised to 2. Okay. Then next term, A raised to 5 and B cube. Okay. Look at here. Powers of A are decreasing by 1 and powers of B are increasing by 1. The next term will be A raised to 4, B raised to 4. So here you will get same power as middle term is there. Then A cube, power of A will decrease and power of B will increase. So B raised to 5. Okay. Then A square, B raised to 6. Okay. Then A raised to 1, so that raised to 1 we don't write, so that is only for your sake of convenience, but when we write the term we will not write the power. And B raised to 7, B raised to 7, and the last term will be A raised to 0 and B raised to 8. So first of all what you have to do, you have to write down first the powers of the terms in the bracket and terms, first term and second term, and when you consider the second term you have to consider pick up it along with its sign. Okay, so then here as every means here as we have plus value, so every term will be positive, so I will give here plus sign everywhere because no negative sign will be there, as we have plus sign in the bracket. When there is minus sign in the bracket, then that time we have alternate positive negative sign. Okay. Okay, so I have given signs here. Now let me first write this as in powers, then you will be able to read it properly. Okay. So all these will be the powers. Yes. So okay. So now if you observe, powers of A are decreasing by 1 and powers of B are increasing by 1. Okay. Now what I will do, now I will furnish this and I will put in the proper format while putting it as an coefficients. Okay. So here now I will put the coefficient 1. Okay. The coefficient is 1 here. Here 1. Then what is the next coefficient? here 8. Anyway, I will not give the bracket so that you will get it. Only for that one I am giving. So here there is 8. Then what is the next coefficient? That is 28. So I will pick it, means here only add, I will drag it here. So here it is 28. Got it? Then what is the next coefficient? Here we have already put this, so I will delete it. Next coefficient is 56. So I will drag it here. Okay, one by one. Then next coefficient is 70. Then I will drag it here. Then 56. So I will just, what I am doing, I am just picking it and putting it in successive terms. So here it is 28. Then here it is 8. And here it is 1. Okay. So now this is the basic thing, basic format which we got. Now we will write it as a final expansion of this. Now let us see how we are doing. Okay, so what is the first term? So 1. So we don't write the coefficient as 1. Okay, so we will not write it as 1. Okay. B raised to 0, that is 1. So also we will not write it. Okay, so a raised to 8 is the first term. Now b raised to 1 we don't write, so that one we will delete. So the next term will be what? A raised to 8 into a raised to 7b. Now here it is okay, here also it is okay, and here now we have to do this as a raised to 1. So we don't write this 1, so it is 8a b raised to 7, and also this 1 we don't write, so I will delete, and a raised to 0 is 1. So now this is the expansion of a plus b bracket raised to 8 using the binomial coefficients. Similarly, if you have the negative sign, right, then I will just copy this. Minus. So now here the first term is what? A is the first term and minus b is the second term. So when you pick up it, you pick up it with the sign. And now here wherever there is b, I will replace it by minus b. I will replace it by minus b. Okay. Minus b. Look at here. So minus b. Here also I will replace it with b. B everywhere we will replace it by minus b. Here also same. I am putting it in the bracket. So you have also, whenever there is negative term, you have to put it in the bracket so that there should not be any mistake of the sign. Okay. So it is minus b. So here minus b power 4. Okay. Then here minus b. Minus b. Because our second term is minus b, so we are replacing it by minus b. So here also minus b. So now when I will write it, when I'll write the proper expansion, here we have to take care of the negative signs. Now here again you forget that negative signs are there, so blindly you give alternate positive negative sign. So instead of here, means as we have this a plus b bracket raised to 8, so if I use this directly, because the steps are same, so here if I use this directly, then here I have the expansion of a minus b bracket cube as look at here. So here as it has alternate negative positive signs, so first term is positive, this term will be negative, then this is positive, this is negative, then this is positive, then here minus, then this is positive, here minus. So this is the expansion of a minus b bracket cube. That is, if you have this expansion, if you can obtain this expansion, then immediately you can write expansion of a minus b, means a minus b raised to 8. Any power here, 8 I have taken, so any power now you can take here using this binomial expansion. So you please remember this so that immediately you can write down this. So here we stop the lecture. Thank you.